Okay, we're going to go through chapter 25, part 1. So, economic growth allows increasing numbers of people around the world to enjoy high incomes and to escape material poverty. Which of the following statements best describes the current limits to growth? So, this is just like straight out of the textbook. So, if you read the textbook, you should get this one no problem. Also, I mean, kind of a secret to multiple choice. I don't know. When in doubt, take the longest answer. So this one is by far the longest. But our two limits that we have to growth is that, well, this is one of them. I don't remember what the other one is, but usually the limit to growth is pollution and environmental degradation. So we can't keep growing at the rate that we are because we're destroying ecosystems and natural resources faster than we're replenishing them. So we just can't have this sustained level of growth. Next question. One important assumption in the neoclassical growth model is that with a given state of technology, so there's two growth models that we have, neither of which have graphs, and they're both, he didn't really talk about them at all, they're from the textbook. So we have the neoclassical and the modern model. What the neoclassical one is saying is similar to what we learned in micro, is just that we have diminishing returns. So if we only increase one factor, so our three factors, we have labor, capital, and then we have technology, right? And technology in the neoclassical model is considered to be exogenous. What that means is that it can't affect the model. That's why there's a given state of technology here. It's a given state, it can't affect the model. So there's two things in neoclassical. If they both increase at the same rate, so if we have an increase of labor and an increase in capital, then we'll have an equal increase in GDP. But if we only have an increase in one, we'll have diminishing returns. So here, I'll show what that looks like. So we have our labor, our capital, and our technology. And I'll do this twice to show both. Oops, that's a little close. Capital and technology to show both. So our technology is fixed, so we're just going to say it's 2 every time. Oh, and we have to have GDP. So it doesn't matter, and there's no actual like units for measuring this stuff, so don't worry. It's just that it's constant. So in the first, I'll show you constant returns to scale. So let's say our labor starts off at 1 and our capital starts off at 1, and we have GDP of 1. Now, if we increase labor and capital both by 1, if we both increase them to 2, our GDP is going to go up to 2, or it's going to go up by the same proportion. If we increase it to 3, it'll go up by the same amount because both of these inputs are increasing by the same amount. Now, let's try another one. So there, it's going to start at 1, and this time, let's leave capital the same. And only increase labor. This is actually going to be a later question, so I'm going to kind of cover this right now. So if we only increase labor to 2, we might see GDP go up to 1.5. And if we increase labor to 3, we might see GDP go up to 1.75. It's not going to go up to 3. We're not going to have constant returns to scale because we're only increasing one factor. And this, like, you can't show it with a graph. It's just a theory, so don't worry too much about it. Just know that you're going to have diminishing returns. So the next part of this is, what does this actually mean for living standards? Let's think about that. What happens if our labor force is increasing? What does that do to our living standards? So living standards is another way of saying per capita GDP. These mean the same thing. So GDP per person, that's our living standards. So let's say our labor force is going up. That's like saying our population is going up. We can think of it that way. So if our population is going up, what's actually happening is our per capita GDP is going down because look, our GDP isn't going up by the same amount. It's not going up by the same amount. So even though our labor force is going up, more people are working. The share of the wealth that they have is less. So our living standards are actually decreasing when we only increase labor. So that's the answer to this one. Increases of one single factor bring diminishing returns. And it's the answer to a later one as well. So this diagram shows that. And suppose the interest rate in this market for financial capital is 2%. Which of the following correctly describes the adjustment? So 2% right here. Right here. So I've drawn this already, sort of. So this is our model here, our national savings and investment model. So this is graphed on the real interest rate and the quantity of investment and saving. And where they intersect, we have the equilibrium interest rate. So this is saying that the interest rate is lower. It's down here or so. So what's going to happen? So, excuse me. Right now, this I, we can think of it as the demand for investment. It's not just investment, it's the demand for investment. And we can think of national saving as the supply for investment, right? This is another demand and supply model with just other names. So right now we have excess demand than supply. What we know is that investment and interest rate are inversely related. So when one goes up, the other goes down, right? If the investment, because you can either invest your money or you can save it. So if the interest rate is really high, you're going to want to put it in a savings account because it's going to get lots of money. On the other hand, you're probably not going to want to invest it for that same reason. So right now there is an excess demand for investment. So what that means is that investment because, so we're moving down this curve. Sorry, I had to think about that for a sec. There is an excess demand for investment. So we want more investment. Problem is it's not there. We don't have the supply for it. So what's going to happen is it's going to push up the real interest rate. We're always going to move back to this equilibrium interest rate right here. Right here. The interest rate doesn't really move in this model. It's just that we move back to it. So how do we get there? How do we get there? The excess demand for investment is going to push up the interest rate, which will decrease the quantity demanded. Let's think about that. If there is excess demand for investment, then people are willing to pay a higher interest rate, right? Everyone wants to invest. They're going to be willing to pay a bit more to get that investment. That's going to move us up here. Then our quantity of investment is going to move this way, move that way, up this way towards equilibrium. And that's going to increase the quantity supplied of saving. It'll increase the quantity supplied of saving, and we'll end up back there, just like that. This one's a little tricky. This is a typical David Johnson type question that you'd probably find on a midterm. What's important is you really think about this, you think about how it works, and take your time, especially with these questions, try to read into them. So what this paragraph is saying is that the government that won doesn't have a balanced budget. So let's talk about what a balanced budget is. So the government budget is also known as public saving, and that is equal to T minus G, right? The amount that the government has is equal to their income minus their expenses. So what they get from everyone is taxes, and what their expenses are their government purchases. So this is their government budget. Then we have private saving, the saving of you and me. And that is equal to our income minus consumption minus taxes. So we start with our income, everything that we want to find out what we save in the end, right? So some of our income, we use it to consume things, to buy food, to buy goods, and some of it we pay towards taxes, and the rest is saving. And then when we add those together, we get national saving. And national saving is equal to public plus private. Or another way of looking at that, NS is equal to T minus G plus Y minus C minus T. So if you look here, if you look at this equation, we have a negative T and we have a positive T. So what that means is that we can actually reduce this equation and just say it's equal to Y minus C minus G. That is what our national saving is equal to. Okay? Also equal to public plus private. So the question was saying that the government doesn't have a balanced budget. What that means is that the public saving is negative. Or, yeah, it's negative. It's not balanced. So that would decrease our national saving. So if we draw that, this is our NS, and this is our demand for investment, I. If we have a smaller budget, then we're going to decrease I. We decrease I. Or sorry, we decrease national saving. National saving. And that, you'll notice, moves us up this curve to a new equilibrium interest rate, right? To a new I star. This is our old I star. It's lower. It's lower. So at that new I star, remember that interest rate and investment are inversely related. So our interest rate has gone up. So what's going to happen to investment? Investment will fall. Investment will fall. We don't know. So I click government spending is rising because that would mean that would give us an unbalanced budget. But it doesn't say in the question that. So investment would fall is the better answer. Government spending rising would cause this, but it's not necessarily the cause. So that's why E is a better answer. My computer fan's going kind of wild right now, but whatever. A person who returns to school to improve her computer skills is an example of an increase in human capital. Human capital is a synonym for knowledge. So anytime they increase their knowledge, they go back to school, or they increase their productivity in some way, like they take a training course, they do a college certification, that kind of thing, that increases their human capital. It's not going to increase the labor force because it just won't. She was already in the labor force, right? It's not increasing technological capital because that refers to the technology that we have, like computers. Physical capital is again referring to like machinery and stuff, and financial capital is referring to the amount of money that we have. That's what financial capital is, and those are all just micro concepts that probably won't be tested on. So now, consider a closed economy, blah blah blah. What is the level of national saving? So we're just going to use this exact formula here. NS equals Y minus C minus G. So it gives us 400. National saving is 400. That's our Y. Minus consumption. Consumption is 250. 400 minus 250 is 150. Minus government purchases, 75. 150 minus 75 is 75. Don't take away taxes, because remember taxes cancel out. They cancel out when you combine them. Next one. So I already talked about this, just like a couple questions earlier. So we noticed that GDP is rising, but falling per capita GDP. So our living standards are going down. Some of these, like GDP rising more slowly than capital, but per capita GDP falling. Like that's not even English. So you can expect a couple of those from David Johnson. Just be aware of them. They're probably not right. And if they are, he'd probably remove them, or you could argue them. This one, if real income grows at approximately 4% per year, the number of years it will take for real income to double is approximately. In economics and just in math, we have this thing called the rule of 72, which says that doubling time is equal to 72 divided by your growth rate. That's it. It's literally just math. So we're going to just do 72 divided by, what did it say? 4%. 4%. And that equals 18. What's important here is that this 4%, think of it as 4, not 0.04. You can get rid of this percent. You can get rid of that percent. It's not 72 divided by 0.04 because you're dividing by the growth rate. It's just, I didn't make it up. The textbook barely goes into it. It's just the time for anything to double. It seems like a kind of a useful concept. And so that's literally just plugging into the formula. Okay. Living standards. Living standards are a measure of per capita GDP. We talked about that already. So if there's a growth in per capita GDP, that means living standards have gone up. This one, I clicked the wrong one. What can you do? But consider the long-run theory of investment, saving, and growth. For a given level of national income, a decrease in private consumption or government purchases will cause the equilibrium interest rate to. So remember our formula. NS is equal to Y minus C minus G. Pretend those are all capital letters. I'm too lazy. So we said there's a decrease in private consumption or government purchases. So either C or G went down. So we have negative signs in front of both of those, which means that they are inversely related, right? So an increase in one will lead to a decrease in the other, and vice versa. So this says a decrease in private consumption or government purchases. So if either of those go down, national saving is going to go up. It's going to go up. So what happens if national saving goes up? This is R and S, and here is our I. If national saving goes up, and S2, we find a new equilibrium over here at a lower interest rate, right? This is old. Here's the new. Remember that this is the interest rate, the real interest rate, and the quantity of investment and savings. So it'll cause the equilibrium interest rate to fall, to decrease, and the flow of national saving to increase, right? We just proved that with the formula. The national saving is going to increase, just like that. And that's it for part 1.